Hello, so in this video we will talk about the multinomial distribution and we will introduce it and we will solve an example for that. So let us consider an experiment that can result in one of r possible outcomes with the ith outcome denoted by xi, and I can go from 1 to r. And let the experiment will perform n number of times independently. So and additionally we also say p of xi, this is equal to sum xi, this is equal to pi. Okay, so this is a short form we will use. Okay, and what is the probability of a joint probability of the event that x1 happens x1 number of times, x2 happens x2 number of times, and so on up to xr happening xr number of times, where obviously the sum of all these numbers should be equal to n, because we have n number of times we perform the experiment n number of times. So how do we proceed this? So we'll say probability of this guy x1 is equal to x1 up to xr is equal to xr. This is equal to number of ways to choose a combination, or the combination if you want to say, times probability of that combination. So what is the number of ways we can choose from n such that one type has x1, second type has x2, can we choose from n such that x1 has a count of x1, second type has a count of x2, and rth type has a count of xr. So this is can be written in two ways. We can write it in combination form x1 x2 up to xr, or we can write it in factorial form, n factorial divided by x1 factorial x2 factorial up to xr factorial. So this times the probability of that combination. The probability of having pi having xi number of times is xi, because they are independent, and then so p1 x1, p2 x2 up to pr xr. So this guy is known as the multinomial distribution. Okay, we have multiple variables. We have the degree of freedom is what? R minus 1, because we can choose any r minus 1 number of x's independently, and that last one will be just 1 minus the sum, or sorry, n minus the sum. Okay, and what is the relation to the binomial distribution? So the relation to the binomial distribution is that you put r is equal to 2. If you put r is equal to 2, r is equal to 2. So if you put r is equal to 2, what do we get? We get n x1 x2 p1 x1 times p2 x2, and since x2 this is equal to 1 minus x1, this is exactly the binomial distribution for us. And PMF adds to 1 for all possibilities. So for this, note this. So if we have P1 plus P2 plus up to Pn, not Pn, Pr to the power of n, what is this? This is exactly equal to x1 up to xr, and then we have n factorial x1 x2 xr times p1 x1 p2 x2 up to pr xr. So this is equal to what? Where the sum of all xi's should be equal to n. This is equal to what? This sum, these are probabilities. So So they should always add up to 1. So this answer is 1 to the n. So this is 1. Okay. Okay. So now let's do an example. So this is a very simple example. We have probabilities that 50% of the customers will buy one type of TV, 20% of customers buy a second type of TV, and 30% of the customer they don't buy anything. Okay. Now if 5 customers enter the store, so this means we have n is equal to 5. What is the probability that 2 of them will buy a smart TV? So we have probability of x1 is equal to 2. One will buy a second type of TV, so this is 1, and 2 will buy nothing. So this is equal to what? 5 factorial divided by 2 factorial, 1 factorial, 2 factorial. What is the probability of the first part? First type 0.5. How many do we need? 2 here. So 2. Then similarly 0.2, 1, and 0.3, 2. So this number is 0.135. Okay. 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 So this is it about the multinomial distribution, starting with the introduction and some relationship to binomial distribution, and how can we prove that they add up to 1, the PMF adds up to 1, followed by a simple example, very simple example. So hope it was easy to understand here. Hope it was clear enough. Thanks for watching and hope you liked the video.